Okay. Yeah, so there's this notion about which is it better data that is better than better models. I think at the end we always say when you have better data, you end up with better models. So there are things that we have to look at to be able to get the three core qualities of good data, which is like accuracy, reliability, and statistically sound data. And these are some of the challenges that we go through on a day-to-day basis in the data management area. Some of these things are design related, like for example, laxity in the database, CRF design issues, or we end up with inconsistent values or missing data in the manner and nature of how data is being collected. Sometimes you may end up with missing data. Sometimes you have programmer issues, formatting, date errors, and things like that. So these are things that catch up with us most of the time when going about the data management activities. So the challenges that we have can be summarized into this complexity of the setup. So most studies nowadays have integration model where you have clinical data connected with some social demographic data, which is also connected with some lab samples and lab activities and lab results that have to be integrated. So it's a complex setup to be able to manage. And mostly you have different systems collecting these different types of data. And then you have to correlate them together, bring them together and merge them and be able to make sense out of them or clean for further analysis. So sometimes you have infrastructural issues, different capacities at site, different training levels for the different sites, different procedures altogether. Some sites have systems, other sites are using paper systems. So you have to merge between all the different capabilities at the site level and see how you can be able to bring up data quality at the same time. Some cleaning issues, timing of data cleaning queries. Sometimes you're sending queries to the site and the participants have left for home. So you have to know how you are timing your queries and how the follow-up is going to be done and things like that. So again, those are some of the challenges that we end up with. Standardization also is a very common one for multi-center studies. Different data teams will provide different reports, so centralizing these things is very important to make sure that you have a consistent approach in your reporting and how often and what information is provided at what time and at what point. And finally, data reporting, having a single point of truth is always very desirable when doing your final reports. So we need to see a system that is able to monitor data in real time as it comes in, able to do some cleaning queries and activities automatically and very quickly, timing in with some time sensitivity in mind, access to standardized reports, and also in the process improve the productivity of data teams. So this is what we did. Our processes were merged up together with the study activities. So the rectangle on top, and it has the 4 steps in blue are the study timelines from study design to execution. And then below we have the data cleaning activities that were happening. And below that are some of the systems that we've deployed to help us with the work. So during design, we enforce some of the rules, things like making sure that data is collected during 24 hours, adding in all the validations and checks and things and that, so that things are watertight enough. And again, that's also negotiable with the study team to see the level of laxity that you can allow so that you don't enforce rules that are not implementable at production. So you have to have that discussion. And then during data collection, we look at things like real-time data visualization. How do we see it as it comes in? How do we resolve queries as they come in and things like that? And then finally, during transformation, we look at the data curation processes to be able to transform this data and have a final data set. The good thing with this is that at the end of the day, we need to have all the procedures well thought and beforehand, so that we have the scripts written, so that by the time the study is beginning, you already can produce a copy of the data set that can be used for analysis, and then you run the activities in iteration mode, so that you collect, clean, and run, and all the time what you are doing is you're just doing process improvement, but the whole system has been put in motion. And so that is what we did. So we implemented a real-time dashboard here to help us look at the reports and things like that, which I'm just going to show you shortly. And we have some activities using a task management system for following up on tasks and how to do the actual cleaning. So how we did it, we put together systems in place. So we have the data collection database here. For this study, we used Alia, but our most popular data collection platform is RedCap. So for most of the cohorts observation studies, we use RedCap. We usually enforce some level of second person verification before we enter data for systems that are not doing electronic data collection, direct electronic, but now we've moved to electronic data collection. So the step for the validation is done within the system. So once data has been entered, it is validated and is confirmed within the system. The good thing with this platform is the backend, whereby we pull the data from the back door using an API into RStudio, and then we develop reports from using using RShiny, and these reports are published through this URL, through a URL to the site staff, who now look at the queries as they come in and resolve, and the whole procedure can repeat itself. So once the queries are resolved, then the extraction is done. So in a typical environment, we refresh the database every 30 minutes to just get latest information coming from the data sources and into the reporting tools, so that we can be able to see what has happened. And so these are some of the tools that we have used. The middle one here, Kilifi Integrated Database Management System, is an internal lab system which we built from the ground up ourselves with the help of our IT department. But the rest are open source tools. RedCap is not really open, but you get an sort of like access through writing to a consortium. So if you have a non-profit organization, which I think most research organizations are non-profit, you're able to get a free license that you can have a copy of RedCap. RStudio and Shiny are open source and are readily available. So some of the things that we've achieved with this risk-based approaches. So we've implemented a risk-based approach whereby we are able to map out the risk areas of the protocol, and then by extension of the CRFs, looking at what information is likely to get missed or getting entered wrongly. Then we automate those processes and pick those queries, so to say, and add them onto the visualization system, and we're able to be comfortable and say, if this dashboard is clean, then our database is clean. So that's a proactive risk-based approach. Real time, so as every 30 minutes data is getting refreshed and we're able to resolve these queries. Data inconsistency, so that we make sure that we detect things that cannot be detected at data entry, things like correlations between variables or between time points and things like that. So those are things that we may not be able to enforce during data collection at the database level, but you can do it at the reporting and cleaning stages, which we have done, and standardizing some of the reports so that people can download similar reports despite them working in different sites. As long as they're working on the same study, then they have access to these reports that they can share with their management teams for further reporting. And also providing utility reports to help future planning and things like that. So I think I'll just go straight to the dashboard itself and just show you a few slides on the interface. Sorry, I am out of office, so I need to log into our 40 client. I need to log into our firewall. Okay, so this is the dashboard. We have several studies that we are doing. So Viritubisho is a study for pregnant women and non-pregnant women. It's more about nutritional supplementation. IBAMI is also a study for breastfeeding children, trying to see whether the breastfeeding peer support, providing breastfeeding peer support is an intervention to enhance or improve the exclusive breastfeeding recommendations from WHO to try and see that is enforced. And the rest are still under development. SNP Africa will be a study about some it's more of a lab related, some lab cultures, blood cultures that will be collected for children enrolled to find out how the cultures affect things like malnutrition and things like that. And the rest are still under development. So I'll just go into one of these studies. The good thing is that we've done the dashboard, like this is version 2. So we are building it to be data agnostic, not to be dependent on the data. So the dashboard itself can run and operate with rules written beforehand, so that when you are now bringing in your data and loading it onto the dashboard, you are specifying that these rules are applying to these data sets, and then you specify the variables in a setup, sort of like a settings environment. So let me open this settings tab just to show you what I mean by the rules. So we generate the rules, like for example, for the BAMI2. So we have the data sets here. So what I call data sets are specific data variables, or let me call them data frames, specific data frames that the data managers write. Then these data frames, we attach them with the rules. So we say, like, if you want to check for like generate a weekly summary, or generate a plot, or do a particular query, so you just specify the rule. So like if I edit one of the rules, let me pick one that has a query like missing data, for example. So this rule is looking for missing data, and the target variable is date of birth. And then the system has already been built to pick that if the role type is missing data, it goes for the missing target variable, date of birth, which is provided as a metadata here, and will return the rest of the fields that have been specified as the return fields. And so it works in a sort of like a smart way, quote unquote, with data provided through the meta tables. So this is how it works. So all these boxes and stuff are just provided through that meta configuration environment, whereby things are configured and then loaded onto with their data sets. So I'll just show you a brief example of, like, for example, these are some of the summaries that you can see, reasons not eligible, and with their percentages there. I'll also show you an example of a query. So like these are some of the queries: missing date of birth, missing gender, missing weight, missing length. So for example, missing length, there are several children here. I think for this study, we were trying to collect the Z-score instead of the raw values. Then we came and revised and said we also need to get the raw values in case the Z-scores cannot be calculated because they're very low. Some of the children are quite either quite sick or quite stunted, and so they may not be able to get the Z-scores. So we decided to collect the raw values a bit later. So we have 8 participants that we have to go back and get their length from their hospital records. So this is an example of a query. And so to sort of like pick this query and work on it on the study database. The study database, like RedCap uses nodes, which we implemented not to files, but other platforms like the other databases that we are using, Dasima, Alia, they have query modules, and you can be able to attach the query ID here. So you put a number and you say, okay, then it will go on and fetch the query itself and bring it, so that in case the query is resolved, it reports that this query is resolved from here, and then in the next refresh, the item will disappear. So that is an example of how we resolve queries. We also put in, maybe let me just show you one thing, the calendar. So for follow-up, we've put in some trackers so that the study teams can know. Like for example, this study, there is 3 follow-up time points, month 6, month 9, and month 12. And they can read through the tables here and see the data. But if they want a visualized report, like a calendar, they can also do that. We've visualized it in a calendar. And they could pick, for example, I know in March, there'll be some follow-up activities. So let me just show you that. So for month 6 in March, there's going to be follow-up. So they will know that this participant is expected for their month 6 on this date. And there's a window period if they want to go and look at the visit schedule, they'll know from which date they can contact the participant and come. And so we try to cover for all the CFFs. So what we do is we just add the queries and decide, like for this variable, let me get the histogram, or let me get a scatter plot here and things like that. And we map out the sensitive areas of the study and visualize them here. So I think I'll stop here and pick any questions. Thank you.
That was amazing. Thank you so much, Narshion. Does anyone have any questions? I see Kwaku has posted in the chat. He's interested in the calendar.
Oh, it's interesting. Okay, yeah. Thanks. Yeah. It's one of the nice utilities.
Yeah, there's so many cool functions. I had a quick question about the RedCap data. You said you use an API to sort of import it into. Is there an R package for RedCap as well, or do you just import it like as a CSV as per regular?
There is an R package. It's called RedCap API.
Okay.
Or something like that. It goes with something like that, such as data name.
Okay. Makes sense.
I will look it up and tell you exactly the name of the library. But there is an API that we use. Yeah.
Thank you.
Okay.
Hello, Ashima.
Hi. Yes.
But then, if you go to RedCap, they actually provide you a script that can extract the data in R.
Ah.
And in Python, in C#, I know at least these four, and Java, yeah.
Okay.
And even using curl. So
it's called RedCap API. There's a
yeah.
Let me put it on the chat.
In my experience, using the R package sort of is slower than using the function or the code written on RedCap.
Okay. That's good to know, because I know RedCap is pretty widely used. So it's great that it's interoperable with so many different software. Oh, thank you, Narshion.
But Narshion, that's a great use of Shiny. I've never seen anybody implement a calendar in that manner.
Oh, in this manner.
Yeah.
There's the calendar R package. Let me put it here.
Calendar R.
Yeah, calendar R. Look at the spellings. Yeah. So
I
that's
guess
an
you can
R package. It has the calendar module, but you have to really twinkle with it to get it to work the way I've made it.
I guess
my code is not yet on GitHub. Yes, it is on GitHub, but it is on private. It's on a private repo. So I'll talk to my bosses and see whether we can open source it at some point. But the moment we have it on on a private repo on GitHub. But happy to help you set up anything that you may want.
And Narshion is the shiny expert, so anyone, if there's any questions, please redirect them to Narshion.
Yeah.
Hello, Nash. I guess we can add R to any sort of noun. You have a package for that.
Yeah, looks like. Yeah, there's a lot of packages in R.
Okay, this is very interesting.